Hey everyone, these are the percent part whole guided notes. Let's get started. We are first going to do a review of equivalent ratios. Equivalent ratio is two ratios that express the same relationship between numbers. An equivalent ratio will also have a multiplicative factor, both horizontally and vertically. Let's look at these equivalent ratios right here. What is the multiplicative factor going horizontally? So we're looking for the number that I can multiply the numerators by and the denominators by. So I can go 2 times 2 is 4 and 6 times 2 is 12. The multiplicative factor going horizontally is 2. What is the multiplicative factor going vertically? So now we are looking for a relationship between the numerators and the denominators. So 2 multiplied by 3 is 6, as well as 4 multiplied by 3 is 12. So the multiplicative factor going vertically is 3. Sometimes the multiplicative factor is not a whole number. Let's look at this equivalent ratios right here. What is the multiplicative factor going horizontally? Horizontally, I can go 3 times 5 is 15, and 5 times 5 is 25. So the multiplicative factor is 5. Now there is also a multiplicative factor going vertically. 3 times some number is 5, and 15 times some number is 25. Now that number may not be quite as obvious as the one going horizontally in this case, but there is still a multiplicative factor going vertically. It is just not a whole number with these ratios. Let's look at this ratio right here. It says, what is the multiplicative factor going vertically? So in this case, 4 times 3 is 12, and 7 times 3 is 21. So the multiplicative factor going vertically is 3. There is also a multiplicative factor going horizontally. 4 times some number is 7, and 12 times that same number is 21. It's just not quite as obvious. So you can look for both the multiplicative factor going horizontally and vertically, and you can use whichever one you want. Write 3 ratios that are equivalent to 5, 6. So let's multiply by 2, and I get 5 times 2 is 10, 6 times 2 is 12. Now if I multiply by 3, 5 times 3 is 15, 6 times 3 is 18, and then I can also multiply by 4. 5 times 4 is 20, and 6 times 4 is 24. All these ratios are equivalent. Now I can do the same thing down here with 4 eighths, but I'm going to do it vertically. So 4 times 2 is 8. So I can have a numerator, let's say 5, and if I times that by 2, I would get 10, and that's another equivalent ratio. Or I could do 6 and then times 2, and that is 12. Or I could do 7 times 2, and that is 14. So these are all equivalent ratios. Now we are going to look at percents as rates. It says 9 out of 25 students in the class have black hair. We want to determine at the same rate how many students out of 100 would have black hair. We will do this with an equivalent ratio. So we have my 9 out of 25 right here, and then my whole on my second ratio is 100, because we want to know how many students out of 100. So 9 out of 25 is how many out of 100. My wholes are in the denominator. Now I can look for multiplicative factor either horizontally or vertically, whichever one was easier to work with is what I'm going to use. I noticed 25 times 4 is 100, so 9 times 4 is 36. 36 out of 100 would have black hair at that same rate. Now it says write the rate out of 100 as a percent. That will be 36%, because remember that percents are ratios out of 100. So 36 over 100 will be 36%. 7 out of 10 people like tomatoes. Let's determine at this same rate how many students out of 100 also like tomatoes. So I have my rate right here, 7 out of 10, and I want to know how many out of 100. So my wholes are both 10 and 100. I'm going to look for a multiplicative factor here. I notice that 10 times 10 is 100. So applying that to the numerator, 7 times 10 is 70. Write this rate out of 100 as a percent. So that will be 70%. 70 out of 100 is 70%. 42 out of 60 cookies were sugar cookies. At this rate, how many cookies out of 100 would be sugar cookies? So let's set up my ratio, 42 over 60, and then my whole is going to be out of 100. Now there is a multiplicative factor between 60 and 100, as well as 42 and 60. It's just not quite as clear. So I'm going to convert it to tenths and then go to hundreds. And that's a little strategy you can use. I could also take 100 divided by 60 and figure out what the multiplicative factor is and do it that way. Let's first simplify to tenths. So 6 divided by 6 is 10. So 42 divided by 6 is 7. And then I can go 10 times 10 is 100 and 7 times 10 is 70. Practice. Write and solve an equivalent ratio to answer the question. Write your answer in the box. 3 out of 5 students in the class were boys. At this rate, how many out of 100 would be boys? So my ratio I'm going to start with is 3 out of 5, and I want to know how many out of 100. So again, 100 is my whole and 5 is my whole. I'm going to look for a multiplicative factor either vertically or horizontally. I notice that 5 times 20 is 100, so 3 times 20 is 60. Again, if you don't know that 5 times 20 is 100, you can always divide. 100 divided by 5 is what number? And that will give you your multiplicative factor. So at this rate, 60 would be boys. 7 out of 20 students chose art as their favorite class. At this rate, how many students out of 100 chose art as their favorite class? So writing my ratio, 7 out of 20, and then out of 100 for my equivalent ratio, I'm going to look for a multiplicative factor. I don't see one quite quickly between 7 and 20, although I could divide and figure it out. But again, I notice that 20 times 5 is 100, so 7 times 5 is 35. So at this rate, we would expect 35 students to have art as their favorite class. 4 out of 25 coins in the bucket are dimes. At this rate, how many coins out of 100 would be dimes? So let's write our ratio, 4 out of 25, and then out of 100. Looking for a multiplicative factor, again, I can see it horizontally. 25 times 4 is 100, so 4 times 4 is 16. Again, if you don't know that 25 times 4 is 100, I can divide 100 divided by 25, and that will give me my multiplicative factor. So we would expect 16 coins to be dimes. 32 out of 80 students went to the basketball game. At this rate, how many students out of 100 would go to the basketball game? So writing my ratio, 32 out of 80, and then out of 100 is my other whole. Looking for a multiplicative factor. I don't know what 32 times what is 80, or I don't know what right off the bat 80 times what is 100. I could take 100 and divide it by 80, and that would give me 1.25. Or I could also try simplifying 32 out of 80 and go that way. So let's do that way as well. So 32 divided by 80 simplified. I can divide both of those by 8, and that gives me 4 tenths. I can multiply 10 times 10 to get 100, and 4 times 10 is 40. 40 students I expect would go to the basketball game. Now let's determine the percent of a number. What is 25% of 60? We will first use a bar model. So we are going to draw a bar model right here. So you have a bar already drawn for you. And it's asking us how many times will 25% go into 100? And that's going to be your first question, is how many times will the percent go into 100? If you don't know, you can divide 100 divided by 25, but you should know, hopefully, that that is going to be 4. I'm going to take my bar and divide it up into 4 sections, because if this whole thing is 100%, that means each section will be 25%. Now it's asking us what is 25% of 60. So now 60 is also my whole. That means I need to take 60 and divide it up into 4 sections. So 60 divided by 4 is 15. That means each section will be 15 because 60 divided by 4 is 15. Therefore, 25% of 60, so 25% of 60 is just going to be one section, and that will be 15. I can also use equivalent ratios to calculate 25% of 60. 25% as a ratio will be 25 over 100. Set that equal to another part to whole ratio. In this problem, 60 is the whole, because we are trying to figure out 25% of 60, or 60 as the whole. And you want to determine the part. So setting up my ratio, 25 over 100, and I write 60 on the bottom with 100 because those both represent the whole. I am now going to look for a multiplicative factor. I can go horizontally or vertically. I notice right here, 25 times 4 is 100. So some number times 4 is going to be 60. To figure out that some number, I can do the reverse and I can divide. 60 divided by 4 will give me 15. And notice that is the same answer I got with the bar model. Calculate 20% of 500. How many times will 20% go into 100%? So if my whole bar represents 100%, I can go 100 divided by 20, and that gives me 5. That tells me I should divide up my bar into 5 sections. That means each section will be 20%. So I have 20, 40, 60, 80, 100%. If 500 is the whole bar, then each section will be, so I need to take 500 and I need to divide that into each of these sections. So I'm going to divide it by 5. That means each section will be 100. Because 500 divided by 5 is 100. Therefore, 20% of 500, so 20% of 500 will be 100. I can do this also with an equivalent ratio. Let's finish setting up the equivalent ratio. So my percent is 20%. So that will be written as 20 out of 100. My other whole will be 500. So that's going on the bottom as well as the 100. I need to figure out the part. So here's my equivalent ratio right here. I'm going to look for a multiplicative factor. I could have also noticed the multiplicative factor vertically. 20 times 5 is 100. So some number times 5 is 500. And if I want to figure that out, I can divide. 500 divided by 5. That will give me 100. What is 10% of 80? For the bar model, how many times does 10% go into 100%? So 100 divided by 10 is 10. That means I'm going to create 10 sections on my bar model. You're just thinking of ways to get the percent shown out of the 100%. Each of these sections will be 10%. Now, if 80 is the whole bar, so I'm going to take 80 and I have to divide that up into 10 sections. So I will go 80 divided by 10, and that gives me 8 per section. Because 80 divided by 10 will equal 8. So what is 10% of 80? 10% of 80 would be one section, and that would be 8. Now let's solve the same problem using equivalent ratios. So 10% of 80. 10% will be 10 out of 100, and then 80 will be my whole as well. So that will go in the denominator. So here is my ratio set up. Now I'm going to look for multiplicative factors. I notice vertically that 10 times 10 is 100. So some number times 10 has to be 80. If I don't know what that is, I can go 80 divided by 10, but that will also give me 8. What is 30% of 50? Notice that 30% does not go into 100% equally. Like I can't go 100 divided by 30 and get a whole number. But we can break 30% into 10% plus 10% plus 10%. So if I want to model 30%, I'm going to do that in groups of 10. So let's break this bar model up into sections of 10, and each of those will be 10%. Now, if 50 is the whole, I've got to divide 50 into 10 sections. So 50 divided by 10 is 5. Each of those sections will be 5. To determine 30%, however, we need to look at 3 sections because remember each of these is 10%. So 10, 20, 30, that would be 3 sections. Therefore, 30% of 50, it will be 15 because I have 5 plus 5 plus 5, 15. Doing this with the equivalent ratios, my percent is 30%, so we are going to write 30 out of 100. My whole is 50, and I want to figure out the part. Looking for multiplicative factors, I notice that 50 times 2 is 100, so some number times 2 has to be 30. If I don't know what that is, I can divide. 30 divided by 2, and that gives me 15. My part is 15. I'm going to answer these with both the bar models and equivalent ratios. That's not always necessary. I'm just showing you multiple ways to solve the problem. What is 25% of 44? Let's start with the bar model. This whole bar model is 100%, but I need 25%. So 100 divided by 25, that will give me 4. So I can divide this up into 4 sections. Now my whole is 44. So if I have to take 44 and I need to divide that up into 4 sections, 44 divided by 4 is 11. So one of these sections is 25%. Therefore, 25% of 44 will be 11. Using equivalent ratios to solve the problem, 25% will be 25 out of 100, and that is equal to my part over 44. Now I'm looking for a multiplicative factor. I can notice vertically 25 times 4 is 100. So some number times 4 is 44. If I don't know what that is, I can divide. 44 divided by 4 equals 11. What is 20% of 45? 100 divided by 20 will give me 5. So I can make a bar model of 5 sections. If this whole bar represents 100%, that means each bar is 20%. Now my other whole is 45. So this is 45. So each section is going to be 45 divided by 5, which is 9. So 20% of 45 will be 9. Using equivalent ratios to solve the problem, 20% will be 20 out of 100, and that is equal to my part, which I'm trying to figure out, over my whole of 45. Looking for multiplicative factors, I can see vertically that 20 times 5 is 100, so some number times 5 is 45. If I don't know what that is, I can divide. 45 divided by 5 is 9. So my part is 9. What is 70% of 50? Let's use our bar model first. To model 70%, I'm going to go 10 plus 10 plus 10 7 times. So I need to divide my bar model up into 10 sections. Each section is 10% out of my whole of 100%. Now this 100% is 50. So I need to take 50 and divide that up into 10 sections. That means each section will be 5. Now it's asking me for 70%, not 10%. So I am going to need 7 of these because each is 10%. So that would be 70%. Therefore, 5 times 7, because there's 7 of these and each one is 5, so 5 times 7 will be 35. Setting that up as equivalent ratios, my percent, 70 out of 100, is equal to my part, which I'm trying to figure out, over 50. Looking for multiplicative factors, going this way, I notice that 50 times 2 is 100, so some number times 2 is 70. If I don't know what that is, I can divide. 70 divided by 2, and that also gives me 35. What is 40% of 25? I can't take 100 and divide it by 40 and get a whole number, but I could break it up into 10% and then do 4 sections, or I can break it up into 5s and do 2 sections. You don't need to do both ways. I am just going to show you both ways so you can see how they are actually the same. So if I take my bar model, I'm going to divide this one up into 10s. And then I'm going to divide the bottom one up into 5s. On the top, each section is 10%. On the bottom, each section is 20% because 20 times 5 is 100 and 10 times 10 is 100. Now my whole is 25. So on the top, if I take 25 and divide it by 10, that means each section will be 2.5. On the bottom bar model, if I take 25 and divide it by 5, that means each section will be 5. Now it's asking me for 40%. So if I use the top bar model, that's going to be 4 sections because each one is 10. 10 times 4 is 40%. On the bottom, that would be 2 sections because each one is 20. So it would be 20, 40%. But notice it's the same value. 2.5 times 4 is 10, as well as 5 times 2 is 10. Setting this up using equivalent ratios, my percent is 40 out of 100, and then that's equal to my part, which I'm trying to figure out, over 25. Looking for a multiplicative factor, I notice that 25 times 4 is 100. Some number times 4 is 40. If I don't know what that is, I can divide 40 divided by 4, and that also gives me 10. Let's look at parts as percents. Let's determine the whole when the part is given. 27 is 50% of what number? We're going to start using bar models, and we will also solve it using equivalent ratios. How many 50% equal 100%? That would be 2. So I'm going to divide this bar into 2 sections, which it is already done for me. I just need to think of a way to show that percent in the problem on the bar model. And that's how you figure out how to divide it up. So 50% would just be 50 and 50. I could also do tens and divide it up into 10 sections, and each section would be 10, and then I would be looking at 5 sections. That works too. So the whole thing is 100%, and each section is 50%. Now this one is different because it tells us my part. It tells me that 27 is 50%, not 100%, but 50%. So now I've got to figure out my whole. Well, if that one's 27, then this one also has to be 27. Therefore, my whole is going to be 27 times 2, which is 54. You can also set up equivalent ratios to determine the whole. So I have my percent right here, 50 out of 100. This time I know my part, so it goes in the numerator with my parts. And I'm trying to figure out the whole, which is the denominator. I'm going to look for a multiplicative factor. I notice that 50 times 2 is 100, so 27 times 2 will equal 54. 12 is 25% of what number? How many times does 25% go into 100%? That will be 4 times. So if I break this bar model up into 4s, that's how I can show 25%, because one section will be 25%. Now I don't know my whole, that's the question, but it tells me that 12 is 25%. That means each of these sections is 12. Therefore, my whole is going to be 12 times 4, or 48. Let's set this up using equivalent ratios. My percent is 25 out of 100. It tells me that 12 is 25%, so 12 is my part and will go in the numerator. I am trying to figure out my whole. Let's look for the multiplicative factor. I notice that 25 times 4 is 100, so 12 times 4 will give me my whole of 48. 15 is 30% of what number? So I need to think of a way to represent 30%. I cannot do 100 divided by 30 because that does not give me a whole number. But remember, I can do 10% plus 10% plus 10%. So let's divide this bar into 10 sections because 100 divided by 10 equals 10. Each of these sections will represent 10%. 15 is 3 sections because 15 is 30%. 30% would be 3 of these. So 15 is this much. It's not my whole, it's still my part. So I have to take 15 and divide that into 3. That means each section is 5. Therefore, the whole bar equals, so this is going to be 5 times 10, or 50. Let's set this up using equivalent ratios. So I want to figure out 30%, and it tells me that 30% is 15. So 15 is my part, not my whole. And so now I'm going to look for a multiplicative factor. I notice that 15 times 2 is 30. Therefore, some number times 2 is 100. And if I don't know that, I can divide 100 divided by 2. And that also gives me 50. 10 is 40% of what number? 40% does not go into 100% evenly. So I can represent it by 20% plus 20%. Again, I can always divide it up into tens and do 4 sections because that would also be 40%. Let's do each section as 20%. So I'm going to divide the bar into 5 sections because 100 divided by 20 equals 5. So each section will be 20%. Now it tells me that 10 is 40%. So 10 was going to be 2 of these. 40% would be 20% and 20%. So I need to take 10 and divide it up into 2 sections. That means each section is 5. Therefore, my whole is 5 times 5, which is 25. Let's solve the same problem using equivalent ratios. So my percent is 40 out of 100, and my part is 10. I'm going to look for a multiplicative factor. I notice that 10 times 4 is 40. So some number times 4 is 100, which would be 25. Again, if I don't know that, I can always divide. Practice. Answer the following questions. Write your answer in the box. Again, I'm going to do these using the bar model and equivalent ratio so you can see 2 methods to solve these problems. It says 20 is 25% of what number? So let's start with the bar model. I can represent 25% on the bar model if I break my bar up into 4 sections because 100 divided by 25 is 4. That means each section will be 25%. Now it says 20 is 25%. So one of those sections will be 20. That means all of them are going to be 20. And so my whole will be 80 because 20 times 4 equals 80. Solving this using equivalent ratios, my percent is 25 out of 100. It tells me my part is 20 and I don't know my whole. Looking for a multiplicative factor, I notice 25 times 4 is 100, so 20 times 4 is 80. 8 is 20% of what number? So I need to model 20% on a bar model. I could divide it up into tens and use 2 sections because each would be 10%, or I can divide it up into fifths and use 1 section because each would be 20% because 20, 40, 60, 80, 100%. So this is 20% right here. Now it tells me that 8 is 20%. So that means all of these sections will be 8 and my whole will be 8 times 5, which is 40. Now setting up equivalent ratios, my percent is 20% and 8 is my part. So that will go on the numerator. I don't know my whole. Looking for multiplicative factors, I notice that 20 times 5 is 100, so 8 times 5 is 40. 40 is 80% of what number? So to model 80%, again, I am going to break it up into fifths. If each one of these is 20%, then I know I will need 4 sections, 20, 40, 60, 80. I can also divide it up into tenths and use 8 sections. That will work as well. So let's mark 80%. That's going to be 4 of these sections because each is 20. So it's telling me that 40 is 80%. So this is 40. So I have to take 40 and divide it up into those boxes. 40 divided by 4 is 10. but that also means this section is 10 as well. So my whole is 10 times 5, which is 50. Setting this up using equivalent ratios, 40, my part over my whole, is equal to 80%. Looking for multiplicative factors, I notice that 40 times 2 is 80, so some number times 2 is 100. If I don't know what that is, I can divide 100 divided by 2, and that will also give me 50. 6 is 30% of what number? To model 30% on a bar model, I'm going to break it up into tens and use 3 sections. So each of these is 10%. So I need to look at 3 sections to have 30%. It tells me that 6 is 30%. So I need to take 6, divide it up into those 3 sections. 6 divided by 3 is 2. So all of these sections will be 2. Therefore, my whole is 2 times 10, which is 20. Setting this up using equivalent ratios, 6 is my part out of my whole, which I don't know, is equal to 30% or 30 out of 100. Looking for multiplicative factors, I know 6 times 5 is 30, W times 5 is 100, or 100 divided by 5 will give me 20. Now we will determine percents given the parts. 5 of 20 is what percent? So I'm given my part, I'm given my whole. So let's set up a bar model first. We need to determine how many times 5 goes into 20. And so I can figure that out by going 20 divided by 5, and that will give me 4. So I'm going to divide this up into 4 sections. So 20 divided by 4 is 5. Each section will be 5. This whole bar is 100%. Therefore, one of these is going to be 25% because 25, 50, 75, 100. So I'm taking 100% and I'm dividing that up. So each of these will be 25%. Explain how you determine the percent of each section. I did 100 divided by 4, and that gave me 25. Therefore, 5 of 20 equals 25%. Let's set this up using equivalent ratios. This time, I know my parts is 5 out of 20. I don't know my percent though. That is my unknown. I can solve it the same way looking for multiplicative factors. I notice that 20 times 5 is 100, so 5 times 5 will be 25. You can see also the vertical relationship here of multiplying by 4 or going the other way would be divided by 4. 3 is what percent of 15? So I need to take 15 divided by 3, and that will give me 5. So I'm going to divide this up into 5 sections. The whole is 100%. This is all 100%. So I have to take 100 and put it into 5 sections. That means each section is 20%. And remember, each section, it tells us right here, is 3. Because 3 times 5 is 15. Set up and solve the equivalent ratio. So my part to whole is 3 to 15, and I don't know my percent, but it will always be out of 100. Looking for multiplicative factors, I notice that 3 times 5 is 15, so P, my percent, times 5 will be 100. I can use division to determine that, 100 divided by 5, and that also gives me 20. 14 is what percent of 28? Determine how to split up the bar model. Well, I can take 28 and divide it by 14, and that gives me 2. So I'm going to do 2 sections, and that means each of these is 14. Now, if my whole is 100%, that means each of these will have to be 50. How many sections did you draw? 2. Because 28 divided by 14 equals 2, and each section is 50%. So 14 of 28 is 50%. Set up and solve an equivalent ratio. So my ratio will be 14 out of 28. I don't know my percent, but I know my whole is 100. Looking for multiplicative factors, I notice that 14 times 2 is 28. So some number times 2 is 100, and that will be 50. Use an equivalent ratio to determine what percent 14 is out of 20. So my ratio will be 14 out of 20. I don't know my percent, but I know my percent will be out of 100. Looking for multiplicative factors, 20 times 5 is 100. So 14 times 5 will be 70. So it will be 70%. Use an equivalent ratio to determine what percent 10 is out of 25. So my ratio will be 10 out of 25. Don't know my percent, but it will be out of 100. Looking for multiplicative factors, I notice that 25 times 4 is 100. So 10 times 4 will be 40, which will be 40%. Practice. Answer the following questions. Write your answer in the box. I'm going to solve these with bar models and ratios to show you 2 ways to solve them. It says 9 is what percent of 18? So let's draw my bar model. 18 divided by 9 is 2. So I'm going to split that up in half. Each one of these will be 9 because that would be 9 times 2 will be 18. So that's set up right. Now if my whole is 100%, that means each of these would have to be 50%. So 9 is 50% of 18. Setting this up using equivalent ratios, I have 9 out of 18. I don't know my percent, but it's out of 100. Looking for multiplicative factors, 9 times 2 is 18. Some number times 2 is 100, and that would be 50. So it's 50%. 75 is what percent of 300? Let's start by setting up a bar model. 30 divided by 75 is 4, so I can split these up into 4 sections. If each of them are 75, that would give me a whole of 300 because 75 times 4 is 300. Now this is also 100%, and so I have to take 100% and divide it into 4. That means one of these will be 25%. Therefore, 75 is what percent of 300? That is 25%. Let's use equivalent ratios to solve it. My part to whole will be 75 out of 300. I don't know my percent, but my percent is out of 100. Looking for multiplicative factors, I notice that 100 times 3 is 300. Some number times 3 is 75. If I don't know that, I can divide 75 divided by 3, and that will give me 25, so 25%. 7 is what percent of 70? So let's start with my bar model. 70 divided by 7 is 10, so I'm going to divide this up into tens. One section is 7, so here's my whole. 7 times 10 is 70. Now that is 100%. So I have to divide that up into 10. Each one of those is going to be 10%. Therefore, since it's talking about what is 7 out of 70, that's going to be 10%. Using equivalent ratios, my part to whole is 7 out of 70. Don't know my percent, but it's out of 100. Looking for multiplicative factors, 7 times 10 is 70. Some number times 10 is 100, and that would be 10%. 5 is what percent of 25? Let's set up a bar model. 25 divided by 5 is 5, so I'm going to divide these up into 5. Each one will be 5 because 5 times 5 is 25, so that shows my whole. That's 100%. So if I have to take 100 and divide it up into sections, that means each section is 20%. So 5 is 20% of 25. Using equivalent ratios, I have 5 out of 25, and that is some percent out of 100. Looking for my multiplicative factors, 5 times 5 is 25. Some number times 5 is 100. If I don't know what that is, I can divide 100 divided by 5, and that gives me 20%. Okay, everybody, that's it for today. Thank you.